to type this data in and to draw the scatter plot and the comment on its correlation. So if we were to do that, sorry, I don't know where it went there. Let me try this again. All right, and so I'm gonna go here. I have already put mine in so that I can be up to date with you guys. All right, so I've got it in. All right, now where do we go to do our scatter plot? Data statistics. So control doc, we're going to go data statistics. We will assign a variable here and we'll assign a variable there. Okay? So there's the scatter plot. So now, according to kind of like what we did last night on our homework, what would you say here? What would be the descriptors here? What are the adjectives?
Positive.
It is positive.
Linear.
Weak. It's probably not strong, probably. Maybe moderate to weak, kind of depend. We probably need a little bit more information maybe on that. Is it linear?
Yeah.
It looks pretty linear, all right? The other thing that we talked about on Tuesday when we discussed is we could get this to draw a line on here. So if we go menu and we go analyze and we run our regression and we were to show a linear, so there is our line on there, okay? Does that help a little bit with your strong, weak, or moderate? It kind of looks a little bit maybe more moderate, all right? It does have some good little trend in there. Now, if I really wanted to know for sure, I kind of want more of a calculation on that. So I'm going to go control doc, and we're going to just add a calculator. So this is the other thing that we talked about on Friday. We talked about Pearson's product moment correlation coefficient last Tuesday, all right? If we were to do that, we go menu, we go statistics, and we go stat calculations, and we ask for the linear regression. Our X list is X, our Y list is Y. It's going to save it there, frequency, all that kind of good stuff. And then I have this. Now, what I'm looking for is I'm looking for the R. So discuss that R with me. 0.764.
Apparently it's strong.
Okay? Where is it as far as the strong is concerned? It's at the very low end of the strong, right? Kind of at the low end of strong, upper end of moderate. So, depending on, I would probably take either one for this. If you told me it was strong, then I'd probably accept it because that's kind of the boundary I gave you. All right, if you told me it was moderate, I'd probably agree with that too. I like things, if I'm talking strong, I like things to be in like 90%, all right? I don't like the 75% or 76 or whatever, especially if I'm using it to make a prediction, okay? And so on this, now, I'm gonna add a little bit more to this one here. So at the bottom of the same page that you have, all right, I'm gonna talk about the best fit, the line of best fit. So the line of best fit. So if we were to do this like we did in our calculator, I'm not going to draw it all out accurately or anything like this, but I had this kind of right here. This is kind of the scatter plot that it looks like I have. All right. The line of best fit, we just drew the line of regression that it had, and it looks something along those lines there. But I want to write an equation for this. Okay. Now I'm going to do this a little bit by hand first. All right, with a little bit of assistance from the calculator. And then we'll check it with the regression line that we have. Okay. Now, if I'm doing this, if I'm drawing a line of best fit, the line of best fit, I think this is on the next page, but I'll go through this, you have this. There's an important point that's on the line of best fit. The mean of each data set. So the mean of the X's and the mean of the Y's, that point has to be on my line of best fit. Okay? So the mean X's and the mean Y's go on there. Then I'm going to draw through that point, and then I'm going to try to balance the other points as best I can. All right? So that's the line of best fit. Well, if I'm going to do that, I can take the table that we have, and I can go find the mean of the X's and the mean of the Y's. So I'm going to go back to my calculator, and I'm going to stay on my calculator screen right here. I'm going to go menu. I'm going to go to statistics. We've done the mean in the calculator before.
Drop something.
I know. I was trying to throw it at you. All right.
Tip came out.
Did it come out?
Yeah.
All right. And then we've done the one variable statistic before. Well, we're not dealing with one variable statistics right now, we're dealing with two variables. So I'm gonna click the two variable one. My X list is X, my Y list is Y, okay? And my frequency, leave that alone as 1. Now, when I hit enter, it gives me a list or a table like I've seen before in a previous unit. If I were to scroll to the front of that, the nice thing about this is it gives me X hat, which is my mean for the X, and it gives me Y hat, which is the mean for the Y. Okay? So I'm going to call this one 6.03, and I'm going to call this one 6.09. So what we would say is our mean for the X and our mean for the Y would be 6.03 and 6.09. And if I were to graph that on my scatter plot, my line of best fit has to go through that point. Okay? Now, I'm gonna write the line of best fit. I'm gonna give me the equation of line of best fit by using some of the algebra that we know in the past. I'm gonna look, my line of best fit goes through the mean, and I'm gonna pick some other number on here, some other point that it goes through nice and easily, all right? The point that I'm gonna pick for the work I'm doing is the 4.53. Why am I picking that one? Well, in my calculator, if I go look at this, my mean would be 6.03 and 6.09, so there's where my mean is, roughly about right there, okay? The other point that looks like it's on my line is that point right there that's really close. And so that's the third one smallest than 5.0. So I went here and I looked that one, that one, that one. It's this point that we're looking at, okay? And so I'm going to use that point to help me. Now, if I have points and I'm wanting to write the equation of the line, what format am I going to use if I have points? Point slope, all right? So I'm going to go y minus y1 equals m x minus x1, all right? The y1 and the x1 in the line of best fit will be your mean. So y minus 6.09 equals m x minus 6.03. Okay? Everybody all right with that? So the y1, the y2 is going to be my mean value. Now, I need to go find the slope. Now, that's why I picked this point right here. I'm going to use it with this point right here to be able to find my slope. How do you find slope? Y2 minus y1, x2 minus x1. So I'm going to go 6.09 minus 5.3. And I'm going to go 6.03 minus 4.9. Now I'm going to use my calculator to assist me a little bit with this. So 6.09 minus 5.30 is 0.79. 6.03 minus 4.9 is 1.13. I don't really like this fraction a lot. I'm going to change that to a decimal, all right? So I'm going to use my calculator to change that to a decimal. So if I were to do that, I'm going to go over here. All right. So, well, a lot of times, yeah, for sure. This whole test is calculator. All right. This whole test is calculator. 1.13. All right. And so I get 0.699. Okay. So y minus 6.09 equals 0.699 x minus 6.03. So there's my line of best fit. Some of you might go, I don't really like the way that that's written. And you'll probably change that to slope-intercept form. How could we change this to slope-intercept form? Multiply this out, distribute, okay? So that would give me y minus 6.09, 0.699x, And then I'm gonna put that in my calculator as well. So, 0.699 times negative 6.03. So I got negative negative 4.21. And then I'm gonna add the 6.09.
Mr. Rice,
Yep.
how did you pick the 4.9 and 5.3?
It was the one that I felt was the closest to the line that I drew.
And why is that important?
Because I'm trying to write the equation of that line. All right. So we'll do one here in a minute. Then I'm going to give you an option on that. All right. And so I'm trying to write the equation of that line. And so I know my mean should be on it and then some other point. And I'm picking the point that's the closest to the line that I drew. All right. Now, if you pick any random point, then I'm going to get a line, but it may not be close to the actual line that I want. It's going to be a little bit more off. Okay. And so, sorry, I'm adding 6.09 here. And so I got 1.88.
So is 1.88 like the minimum height of the?
It's my y-intercept in this problem. So if I were to predict a 0, then that's actually the score that I would get, or whatever, or predict the height. Which if I predict a height of 0 and get a height of 1.88, there's a little bit of error there. And so I have this. Now, here's what I want you to see. So we came up with this by hand. Are there some errors in this?
Yep.
Probably some errors because we did it by hand. We had to do some rounding and all, right? But if I were to compare it, I'm going to go back in my calculator. I'm going to go compare it to the regression line. So this ran the regression. The calculator ran the regression for me. I found the line of best fit by hand, so to speak. And the slope that I got was 0.699. What's the slope here? Is that pretty close? That's not off a whole lot, is it? All right, not bad. I got 0.88 on the 1.88. This is like 1.59. I'm off a little bit, but I'm awfully close. All right. Now, this is what the calculator is doing when they run the regression. All right. It's finding the mean, and then it's finding. Do you remember last year when we talked about residuals? How far data points were off from our model, and we made that line of best squares or whatever. We put all the squares on there. We adjusted it. The calculator is doing that. It's finding the best points to do this. It's still using the mean, right? But it's finding the best points to do that. The point I chose may not have been the best point. It may have been another point in there, all right? And it's modeling that, and it's getting it set. So this is line of best fit. Now, here's the thing. If it asks me to write an equation, then I'm going to use my regression probably. I'm probably not going to do my line of best fit. And but if I ask you the line of best fit, then the point that you're going to have to give me on the line of best fit is the mean. That's one of the biggest things. So if it says what's the important point on the line of best fit, it's the mean x and the mean y. All right. So that's kind of what's taking place there. Because to do all this was quite a bit of work to get here, correct? But I'm just kind of showing you what the regression's doing. All right. Now, let's try another one. So, we talked a little bit about this. We drew the line of best fit. We talked about the correlation coefficient. Now, -1 is really good, but it's a negative. It's perfect negative. Positive 1's perfect positive. And all the values in between. All right. The next one that I want to do with you is I want to do this problem right here. Okay? So here's what I'd like you to do first. I've given you some minutes played, and I've given you the points that were scored. I want you to go take these and put these on your graph. All right, so go and plot them. So we're doing a scatter plot by hand now, not in the calculator. So go and take those and put those on your graph. So graph your scatter plots.
I remember not do this one. Change the whole lot of 17. Cal. Short for calculator. Probably put this in cal. Holy it's like,
Oh, wait, it is like that. I
I think
understand.
we're pretty close. All right, keep plotting if you haven't finished. All right, I'm gonna move on to part B. Part B says identify the correlation. Well, this is basically exactly what you did on the homework from last night. So what would you tell me about this correlation right here from the scatter plot?
positive.
Strong positive. Okay, so strong positive,
Linear.
and it is linear. It looks pretty linear.
Yeah.
All right. Anything concern you about that graph?
That one that's at the bottom.
Yeah, this one kind of is a little bit of concern for me right there.
That means he just sucks.
Right? He just had a bad night.
Yeah.
All right. So playing basketball, whatever, had a bad night that night. So, but we're still going to include in there. But this point is probably maybe dragging it down, maybe making it a little bit more moderate than strong. If that point wasn't there, I'd probably say it's very strong. Correct? Everybody go with that? Now, it says sketch the line of best fit. Well, in order to sketch the line of best fit, what do I need?
The mean.
The mean. Okay, we need the mean. So I'm going to go take my calculator and I'm going to clear mine. So I'm going to go on, I'm going to go new. No, I'm not going to save that. And I'm going to go list in spreadsheets. And I'm going to go put in my points and my minutes. All right, so I'm going to label that X, label that Y. I'm going to go type this in. So I'm going to do 28 and 35. So let's put that in real quick.
Wait, is it? It is on, I don't think it is.
Yes.
Oh, it is? Hello world. How are you doing?
Plug your points in.
They're getting
All right, so I got my minutes played in, and I got my points in, all right? And now, I'm gonna go Control Doc, and I'm gonna just go to my calculator. Where am I going to find the mean? Menu, Statistics, Stat Calculations, and this is a 2-variable statistic, so I'm gonna go 2-variable statistic. X is X and Y is Y. And it gives me a really long list of details. I use the up arrow key, it gets me to the top. So this X hat, what does this 24.4 represent?
Mean.
The mean minutes that I play. So that's the average time I play. All right, and here's my mean Y, which is my what?
mean points.
The points that I score, the mean points, all right? So what I'm gonna do is I'm gonna take those values, I'm gonna put them on here. So 24 and 13. So 24.4 and 13 would go about right there. So now when I sketch my line of best fit, it's gotta go through that point. So to go through that point, it's gonna go through as much of the middle of the rest of the data as I can, all right? So I'm gonna sketch that, and it does something like that. Looks like I moved it a little bit farther. There's a little bit better. Okay. Now, it now says go write the equation. So I'm going to write the equation, the line of best fit. We're also going to get the regression line and see how they compare. All right. And so if I'm doing my line of best fit, I'm going to go y minus y1 equals m times x minus x1. All right. All of our equations should have what in it? We all should be in common with the mean. The mean should be in here. So y minus, this would be 13.1, and this would be 24.4. Okay? Now, depending on how you drew your graph, you may have drawn it different than mine, all right? And you may pick another point other than what I'm going to pick that may be better for you, all right? So our line of best fit is the line that we think best fits, okay? So for me, what I see on mine is I see this one right here. I see 27 and 15 is the other point that hits the line. This one right here, what is that, 15.4? That's not bad either. You could use it, all right? There's another one up here, whatever this one is, 23, no, that's not 23.10. What is that, 28.16? All right, that might be another one. So you could pick a lot of different ones here. So if yours looks different than mine, that's okay right now. I'm going to use the 27 and the 15 is what I'm going to use, okay? And so now, I'm going to use the 27.15 and my x mean, which is 24.4, and my y mean, which is 13.1. I've got to go find my slope. So I'm going to go, what was it, 15 minus 13.1, 27 minus 24.4. Okay? Again, I don't care which point you pick. Well, I do. I want you to pick one that's close to the line or on the line, all right?
So don't pick the outlier.
Don't pick the outlier here, all right? Because if I do that, then basically, if I pick this outlier right there, then I'm saying my line should go there. Now, that doesn't model the data, all right? So I wouldn't want to pick it.
Models the data.
Yeah, not as accurately, all right? And so I'm going to find my slope. My slope here is 1.9 over 2.6. If I were to put that in the calculator so I get a decimal answer, 0.73 what? 0? All right, 0.73, probably call it 1. All right, so my slope is 0.731. So y minus 13.1 equals 0.731 x minus 24.4.
I don't like all these decimals.
Yeah, that's statistics for you. All right, a lot of things don't come out nice, pretty whole numbers. All right, I'm going to distribute and I'm going to multiply. So I'm going to take this right here and I'm going to multiply it by the negative 24.4. So I have y minus 13.1 equals 0.731 x minus, what was it, 17.83? And then I'm going to add the 13.1. Okay, so I got negative 4.73. So y equals 0.731x minus 4.73. All right, that would be my line of best fit.
Doesn't really make sense that you're losing points when you're actually not playing.
Then I'm losing what points?
You're losing 4.73 points in your
Yeah. Yeah, but if you look at my model,
Yeah.
that's kind of where it's directing. Yeah, the model fails in some parts, and we'll talk about that here in a second. I'm glad you brought that up. We'll look at it here in a second. All right. Now, here's what I'm going to do. I'm going to go in and go menu, and I'm going to go statistics, and I'm going to go stat calculations. And this time around, I'm just going to go run to linear regression. All right. So I found the line of best fit, which has the mean value in it. But if I go compare it to the line of best fit, or the regression line, all right, this is the line that they give me, the regression line. This is probably a lot more accurate. But what do you notice about the slope? Pretty close, right? We said 0.731, this 0.774. That's pretty close, all right? We said negative 4.73, this is negative 5.8. It's a little little bit off. It's off by a point, but it's not bad. All right. So we're in pretty good shape. Now, the other thing that I want to look at on this though is my Pearson's product moment correlation coefficient, which is my R value. What is that?
0.89.
0.89 or 0.885 if we're using three significant figures. And so I could take that, and when it asked up here and it says, hey, identify the correlation, we could also say that R equals 0.885. Does that prove this up here? Does that go along with it? Is it a positive number?
Yes.
It is, because if it was a negative correlation, it would have a negative R value. All right? It's a positive number. It is pretty strong. That's 89% or 88.5%. That's pretty good. All right? And so it kind of verifies what we were thinking a while ago. All right? Yes. Yep. All right? Now, last little thing here. Last problem for the day here. According to this model, predict how many points Michael might score if he played for 25 minutes. What do we need to do? Can I get that information from my table? Not quite. Do I see 25 minutes in the table? I see 27 minutes. I see 23 minutes, which 25 is kind of in the middle. I could make a conjecture off of that. I could say maybe 12, maybe 13, all right, there. So I could make a prediction there. But I could also use what? You could use my model or my regression, all right? So I could plug the 25 in. Now, here's what I'm going to do, though. I'm going to use my regression. This is the one that they gave me, all right? That's a little bit more accurate. It's this one right here. It's negative 77. I should put a 5 there instead of a 4, sorry. So that should be a 5 here. Now, here's what I would write on my paper. This is what I would write on my quiz or my test. But this is not what I'm going to put in the calculator. Let me show you a shortcut. You can put this if you like. But remember when we were doing regression a while ago and it saved my equation in the F1? Right? It saved it automatically for me. If I go to variable, the very top one is F1. If I select it, it says, oh, you want to take F1? What do you want to evaluate it at? I want to evaluate it at 25. I want to plug a 25 in there. When I do that, it gives me this result right here, 13.56. So the answer right here in the calculator would be 13.56. I probably wouldn't leave that as an answer.
You'd round it.
I'd probably round it because we're talking about what? Points, right? So in this case, I don't know that it matters. You can make an argument for either one, but he could score 13 or 14 points. Okay? So as this basketball player, if I'm this guy playing this basketball, if I'm seeing that, hey, what's my trend? The more minutes I play,
More points.
the more points I'm going to score. I need to score a lot of points tonight, all right? Coach, put me in for 75 minutes. I'm ready to go,
Oh.
all right? Can I do that?
There's not 75 minutes in a basketball game.
There's not 75 minutes in a basketball game. Somebody in another class said, well, you might get tired, all right? But the idea that there's not 75 minutes in a basketball game is the deal. Look at our data at the top, okay? What is the lowest amount of minutes that this person played? 8. What is the highest amount of minutes that they played? 39. Do I have any clue what it would look like at 75 minutes?
No.
We refer to that as extrapolation. Okay?
Probably like taper off.
It might taper off because I might get tired or whatever. I don't know what the reason, but I don't have anything that can relate to that. All right? So that is extrapolation. Even though I have a really good R value, okay? Even though I have a strong positive correlation, all right? I can't make this conjecture because it's outside of my data set. It is extrapolation. So I would not use this to predict. All right. Now, was 25 okay? Were we okay predicting based off of 25 minutes?
Yeah.
Well, 25 minutes is in my data set, right? It's between 8 and 39. We refer to that as interpolation. Okay? Interpolation means I'm inside my data set. Okay? So to make a prediction, to make a good solid prediction, we have to have a good R value and we have to be inside our data set. Right? If I had something that was an R value of 0.999, but it was way outside my data set, I still wouldn't use it to predict. Okay? So I need two things to predict. We're going to do a little bit more of that tomorrow. Okay? Good? All right. Tonight's homework is the next box, is the next 2 pages. I have finished a little bit early, all right, so that you can have a little bit of time to work on that. Now, one other thing that I'm going to show you.